Alright, let's officially begin the talk now. Hello everyone, I'm Akshya and I'm delighted to welcome you all to another exciting session of TechBrain. For those who joined us for the first time, TechBrain is one of the India's fast-growing and upskilling platforms focused on bridging the gap between the students, real-time learning and the real-world industry skills through practical career-oriented programs in technology. Today's session is specially designed for students who want to understand how to start their career in big data and Hadoop or Spark technologies, one of the most in-demand domains in today's IT industry. Many students usually have questions like, what exactly is big data? How Hadoop is still relevant? How should I learn Spark? How can I become a data engineer? Well, today we'll get clarity on all of these. It's my pleasure to introduce our guest speaker, Mr. Syed Rashid Ahmed, data engineer at WiseAnalytics. He has hands-on experience in working with large-scale data systems and modern big data technologies. Today, he will guide us on the topic, how to start your career in big data and Hadoop or Spark. He will be sharing industry insights, required technical skills, a practical learning roadmap, resume and interview preparation tips, career opportunities in data engineering. Before we begin, feel free to drop your questions in the chat box at any time. We will take them during the Q&A session. Without further delay, I'd like to hand over the session to our speaker. Welcome to the session, Rashid Ahmed sir. The stage is yours.
Hi everybody, this is Syed Rashid Ahmed here. I am a data engineer and I have 2 years of work experience in building production grade ETL pipelines. Before we actually begin the session, I would like to know something about the audience, like who I'm addressing it about. So I would request somebody to unmute and then explain something about themselves. So I would know that to whom I'm pitching the idea and what the audience expects from me. Can somebody please unmute and tell me what is your qualification, like education background, what are you striving towards, and then what is your career aspiration or something like that.
Hi, I'm Devaka. So I'm a data engineer with 4 years of experience. So I'm currently working on a project. So I'm here to get some knowledge with.
Anybody else? Thanks Devaka. Thanks a lot. Anybody else introduce themselves? Okay. So let's continue this session. As I told you, I'm a data engineer and then I have around 2 years of experience in building production grade pipelines. So in this particular session, I would not just explain you who a data engineer is or some kind of definitions about it. I would more likely focus towards what are the industry requirements, what are the skills you must have, or what are people mainly focused towards in big data, what happens if something breaks down, or things like that. So I would say that I have worked on a couple of projects. The most exciting one was financial data ETL pipeline, where we were getting real-time data analysis from APIs, and then we had to make analysis and build machine learning models. So we were getting this financial data, and then we had to build a pipeline which would process around 40,000 financial tickers. So this was one of the as I had to tell you that big data is not a narrow lane, it is a wide spectrum. It can be for pipelines with MLs, it can be for just analysis, or it can be things like that. So one of the project which I was telling was financial ETL pipeline, and then the second one which I'm very fond of is a scraping framework, where we had to scrape all the data coming from a company, the open source data coming from a company. So if at all you just give me the company's name like Apple or Microsoft, I would scrape all the data from it. This would be an automated process, and then the scraped data, be it structured or unstructured, would be pushed into the database. So things like that. And then I also worked on a SQL migration project. So I had to migrate over 500 SQL objects from Oracle to Databricks. there are different types of database management systems, as we know. So I had to migrate from Oracle to Databricks. And then we in big data, we just don't focus towards building a notebook look good type of project. We focus towards efficiency, its performance, what would happen if at all something break down at 2 a.m. in the morning. So nobody would sit at that particular time and try to resolve it. So we focus towards automation. Now, with that being said, I would jump towards what a data engineer is, what are his roles and responsibilities, things like that. Can I present the screen?
Yes, for sure.
Thank you. So this would I'll try to make it as practical as possible, like what the industry requires from us, and what are the basic skill set, if at all you have, you can just dive into big data, and what are the expectations, requirements, things like that. So to begin with, I would like to know that what a data engineer is to you, like what are his roles and responsibilities. Like if at all somebody says that what a data engineer is according to them, even in layman terms, it would be very helpful to me, so that I would try to streamline their thoughts. Can somebody please unmute and then try to explain me what they know about big data?
Sir, big data is like a large amount of data is stored in the data warehouse.
Yeah, but what do you think a data engineer does with big data? What are his responsibilities?
His responsibility his responsibility is to structure the data and then analyze the data and make a model to predict the next prediction.
Yeah, so in this complete process, we would have 3 different professions. We would have data engineers for building this complete structure. We would have data analysts for analyzing, and then data scientists for building machine learning model. So from this being said, I would like to explain what a data engineer is and his roles and responsibilities, things like that. So data engineer is basically a person who is building things. Okay, he is responsible for collecting and storing things. Just this. Just a minute. Sorry. So a data engineer is not just a person who is responsible for collecting or storing things. He is responsible for building the total machine where you can store the data, collect the data, process the data. This complete process, we are mainly focused towards large scale data. And then once he does this, he is also responsible for its reliability, accessibility, and availability. So to put it in simple terms or in layman terms, I would say that data engineer is a person who is building a data highway. So you build a data highway, the data flows through this data highway, and then it reaches the other end. At the other end, you have teams like data analysts, data scientists, who are responsible for doing analysis or building machine learning models and so on. So starting from a thing where data is being produced, where you transform the data, you're pushing it to a place, and then somebody picks up from there, and then they're doing some kind of streaming analytics or VR, things like that. So in layman terms or in basic terms, this is what a data engineer is. In IT, everybody has some kind of roles and responsibilities. So data engineer must also have roles and responsibilities. So let's move towards their core roles and responsibilities. Data engineer is mainly focused on 4 things. He is responsible for data ingestion, the transformation, what he's doing on the data, where he's storing, that is data storage, and this complete process is automated and it is orchestrated. In data engineering, we focus towards building pipelines which is ideally 100% automated, but usually this is not possible, but we try to strive towards building a automated process. So let's start towards the first responsibility, that is data ingestion. Now in data ingestion, what we do is we collect the data from different places. We can collect the data from APIs, from databases, from flat files, from streaming places, and so on. Flat files in the sense we can have from CSVs, from Excel sheets or things like that. APIs, you might know what is API. It is a server which keeps on sending the data and we can just pull the data from it. You can have databases, you can have streaming sources in the sense of Kafka. Usually you have live streaming matches, right? So these are being streamed from Kafka. So from the data ingestion part, you are not just responsible for pulling the data, you are also responsible for handling the data, how you are being pulled. For the APIs, you will have rate limits and retries. So if at all you are getting data, you cannot keep hitting the API like 24/7. This would pull the API down, so companies would not let you do that. So you must also pull the data, ingest the data in a way that you are abiding through these rules. If at all something fails, like how you are going to retry, and then if at all the company is sending you ABCD data, and in future if they start sending you E data and then start removing some column B or C, this would actually cause schema evolution and your complete pipeline would break down. So you must also handle schema evolution. So these are the basic things about data ingestion. Next, we move towards data transformation. Any data what you have in the raw form is not that useful when compared to when it is being transformed. For example, you might have data coming from API, data coming from IoT sensors and things like that. If at all the data is coming from IoT sensors, you would have just the temperature, the time, and then some kind of timestamp or things like that. So, but if you transform the data in a proper format, you can try to predict when the system would break, when the IoT machine would break, or you can make any other type of prediction. So data transformation is very important. This transformation can be of any format. You can remove the nulls from the data, you can try to deduplicate it, remove the corrupt records and things like that. And the most important part in transformation is scalability. We as my friend told here, in big data, the data engineer is mainly responsible towards processing huge volume of data. If you build a system which can process records whose size is around 1,000 or 2,000, it would be very difficult for companies like Netflix or Uber to handle it. So we must focus towards building systems which can handle enormous amount of data, not just work on thousands or 2,000 records, but also into millions and billions of records. So this is the second responsibility for a data engineer. Next, we would move towards data storage and warehousing. Once you transform the data, you must also store it in some place, right? So next time you want to do some kind of analysis or build some kind of model, you need to pick up the data from that particular place. So you can store the data in different formats. You can store it in a warehouse, you can store it in your disk or something like that. And then for storing, it is not just pushing it in some particular place or dumping it. You must choose the right format for it, the right optimization techniques for it, and so on. For example, in data engineering, the big data engineers usually prefer Parquet format because machines in Parquet format focus towards columnar understanding. They read in the form of columns, not in the form of rows. So if at all you have to read some data, instead of reading the complete row, you can just read the column and then move ahead. So the format which big data engineers choose is Parquet usually. So the next thing what we focus towards is the partition optimization strategies. So I can tell you that if at all you're a data engineer and then I ask you to bring a record of a student from roll number 35. So instead of going through millions and billions of students, you can just design an algorithm which will just pick the student from that particular roll number. So in uh, you have a concept in DSA where we try to reduce the time complexity and the space complexity. So we try to do the same in this particular format also. So here what we I can tell you some kind of optimization techniques, like we have partitioning, we have bucketing, we have liquid clustering, and so on. So what we do here is, instead of storing all the students data in one particular database, we divide it in terms of partitions. So students from roll number 1 till 10 will be stored in one particular partition or one block, and student from 20 to 11 would be stored in other particular block, and 21 till 30 would be placed in other particular block. So if I tell you to bring the data of a student whose roll number is 25, then instead of searching the entire database, you can just jump to the partition which stores 11 to 20 and then pick the data. So these are some of the techniques which data engineers use. And then we also focus towards increasing the optimizing the queries. So this, if at all I deeply dive into this process, it would be very lengthy. So these are the basic things how the data is being stored. Next we move towards the orchestration and automation process. Here, as I told you that if at all I ask you to build a pipeline and then ask you to monitor it 24/7 for the next 50 years or 60 years, it is practically impossible and no human has the ability to do it. So what we do, we automate the process and orchestrate it. We build some kind of governance to it and then apply to this particular pipeline. So you orchestrate it and then schedule it for once a day or once a quarter or once a year, and then this pipeline keeps working. So these are the core responsibilities for data engineer. So next, since these are the responsibilities, so you must also have some kind of tools, right, to fulfill these responsibilities. So these are the essential tools for big data engineers. You can have programming. This is the essential toolkit for data engineers. The most uncompromisable part for data engineer is scripting. You must be very efficient in scripting. So in building these pipelines, we usually use Python, as it is very vastly used. You can use Python for big data, you can use for full stack, you can use for game development, you can use for data manipulation and things like that. So I would suggest you to, if at all you are going through this particular profession, go for Python. And then along with this, you must have SQL in your arsenal, because whatever data you're reading or processing, at the end it would be sent to database, right? And then SQL is required, is must required, is very, I do not know how to stress more for this particular thing, but it is the most essential part for your domain. So as the data is being dumped to database, you must have a particular skill through which you can interact with this database. So you should have Python, and then you should have SQL for starting your career into big data. And then we also have this big data processing. The name itself is self-explanatory. Like you will have data in thousands or 2000s or 20,000 or a lakh. But if at all you have data in terabytes or petabytes, you would have to come towards big data. In this, if you have data for millions and billions of record, one single machine will not be able to handle it. So you would have to go to a distributed system where the complete data is divided into smaller chunks and given in for different computers. Now what these computers do is they try to solve this problem for that particular small chunk of data return its result, and then at the end we merge this complete solution into one big solution. This is more like a divide and conquer format. This is also a data structure algorithm. Now we use PySpark, which is a flavor of Apache Spark. This we use widely for big data processing. And then coming towards orchestration, we use Apache Airflow. This is the open source tool which is used for authoring, scheduling, governing the data, making this workflows, and so on. And then next we have containerization. You must be familiar with the Docker. If at all you have a question in between, you can just unmute and then let me know, because I'm on the different screen and I'm just going on presenting it for a long time. If at all you have something, you can just pitch it to me, please. So coming back to the tools, I would say that Docker is essential for containerization. In companies, there would not be just 5 members or 10 members in a team. You would have 50 members or 20 members, things like that. So if you are building something on your particular machine, and then if at all you're not able to clone the same thing into other machine, you would have a lot of problems in it. So to solve this particular problem, we have Docker. What Docker does is it packages the complete application, its dependencies, it's the tools required for it, and then it packages this complete process and then sends to the other environment where the people can unpackage it and then start building it. To put it in layman terms, I can say that consider you're preparing French fries or things like that. So if at all you have to do it, what would you do? You need food for the ingredients for it, like potatoes, salt, oil, and then you would need the grater. You would require a recipe for it. So what you do is you take a big box, you put all the ingredients, the recipe, and the tools for it, and then send it to your friend. So there the friend opens this box and then reads the recipe and start building the things. Like, this is how the containers work. This was explained in layman terms. Like, once you start reading it, you will know much about it. So these are the tools, basic necessary skills set in order to enter into the field. Like, I would love to know something about this particular tool. Like, if somebody has already learned it, he might have some kind of queries or something like that. Can somebody please let me know that how you have learned this, or what is your approach in this tools? What can you tell me about this particular tool?
I have some doubts.
Yeah.
You said in the starting we are working on scraping, right?
Yeah.
Can I know what are the libraries and models you're using for scraping? Like Request or Playwright or Selenium or Playwright framework, or any other new libraries are being used for particular scenarios to handle the automation?
Right. For automation, we were using Selenium. This is the widely used thing for the automation process. So we use Selenium, we use Python for scripting, and the database which we use for pushing the scrape data into is MongoDB, and then we use Airflow for complete orchestration.
I'm asking about the scraping part. I mean, I worked on more project scraping, so I used packages like Playwright, which is also one of the browser automation tool, like with Selenium. Comparing with that, Playwright is lightweighted. We can do asynchronous request. Apart from that, by automation, we can use request library and then scrape framework and then URL link and then HTTP. Apart from this, did you use any new package or new model to scrape any websites?
No, we just use Selenium to it, and for scripting we use Python. And the thing what I would like to tell you about this industry is we are not always working on the new and trendy objects or new and trendy tools. We are also forced towards working towards legacy tools. It all depends on what kind of company you're working. The company in which I was working, the client was mainly focused towards Selenium and this old traditional methods. So I did not have much opportunity to use different things, but the main tool which we were focused was on Selenium itself.
Then what about Spark? So you said we use Spark to get options. Did you use Glue or Hadoop?
Spark is actually a big data processing tool, like distributed data, how you solve it. Like you have Hadoop, right? Hadoop was an older technology where you were storing the data in disk. But in Spark, what you do is you take complete data into in-memory and then you start working on it. I used Python there, but in PySpark I used for a different project. I actually do have a explanation for that particular project where I was using PySpark. So I would be explaining you about that thing.
No, I'm not asking about explanation. Any additional tools or new techniques did you follow for any updated?
These were the tools which I used for the scraping format. Yeah, the scraping project, we just use this particular tool. And then it is not like we do it end to end, right? We have different teams for it. So one particular team would be doing something, and then that other particular team would handle the next part of it. So our team was mainly focused on that kind of scraping format.
In scraping, how you make a API request?
Sorry?
In scraping, how you make a API extraction or API injection? Is it Selenium or in a?
No, we were scraping directly from the
website.
Not website. We were scraping from different places. We were mainly scraping from the website. We were scraping from different sources. We were processing the data from documents, images, videos, audio, different things.
PDF extraction, OCR.
Yeah. We were also focused towards OCR as well.
While we reading PDF, right? We use we will fill
you have tools like
in groupings. In groupings, right? We use if there is any table, we use Camelot on the table. So when we dealing with text, no, we are it is impossible to group the text by using the text. So we are using you are using any models like NLP to get any problem?
NLP is actually when you try to bring machine learning into it, like when you're trying to find the emotions out of the text. So this is the place when you use NLP. But here we were focusing towards extraction of data. Like you use NLP when you take a sentence like, "Hi, how are you? I'm feeling so and so." So you use NLP to find out what the emotion is. But in this OCR, what you do is you do not care about what the emotion is. You just try to extract the text and then push it to a particular storage format. So what you're trying to do is you're mixing one domain with other domain.
Saying about NE or change name entity recognition. If we are dealing with some, we are extracting the data from a PDF, right? So we will get a read as a text. So while mapping, sometimes the PDF may be in a different structure, right? All the PDF cannot be the same structure. So in particular part, we use name entity, which is automatically group the text by the name and then organization will split by that. And did you use any type of abstraction part for classification of text while extraction?
Are you talking about the entity relationship
exactly.
mapping? Yeah, we have the ML side out of it for that, where they where they create a graph database and then try to push it to a LLM and try to use a RAG out of it. What I am trying to explain you is we are responsible for pulling the data, transforming it, and then pushing the data, right? So what you are telling is NLP would come towards the machine learning part of it. And then entity relationship would also be in the machine learning. what you are getting confused, I can understand that initially everybody would face the same problem. Big data engineer and data engineer is completely different from data scientist. Data
Not like
engineer,
that. Actually,
yeah,
they did some project while we are dealing with unstructured data, right? So in unstructured data, we can't able to group all the unstructured data into structured format when we are following some patterns. So to come up with those things, we have create some models to which we change the unstructured data into a structured format. How some type of automation like model which can able to extract the information from the raw data. So we did some model based on that. So I'm asking, are you doing
I think you were working on OCR, right?
even mostly?
Sorry.
Yeah, it's include OCRs.
Okay. So, what's the question, or what do you want to ask about this?
I need to know any other new packages, or you using any any new models, which I can know that model and I will learn those models.
Yeah, you can. As far as I know, I was not into that particular domain, but as far as I know, you can use PyTesseract for OCR, and then you can also use NLP. Then you can also use OpenAI's some model where you can just read the text and then try to get out get emotion out of it. So you can use things like that, but practically I have not got the opportunity to work on the ML part of it, but if at all I had this opportunity, I would use PyTesseract and then some models from OpenAI, which are very widely being used now. Yeah. Thanks, Divakar. So this was the part for automated scraping, right? So I would explain you a bit about a financial ETL pipeline. This is completely purely big data engineer project which I had done. This was a real-time analytics project. So here what we were doing is financial data ETL pipeline. This was the title which we had given for this particular project, where we were focused towards processing around 40,000 financial tickers. Each ticker is something, you get some data about one particular company. For example, at a particular instance, what is the stock value for Apple, what is the stock value for Goldman Sachs, right? So we were using the API and then pulling this particular data. This was a complete production grade pipeline, and then we were using PySpark here. So this PySpark we were using for big data processing, right? So what data is, how the transformation is done, all these things can be handled with PySpark. And then we were using Airflow for this orchestration, PostgreSQL as the data warehouse, and then we were trying to build an end-to-end pipeline, and we were mainly focused towards error handling. Like example, if something breaks down at 2 a.m., what we can do. So what we do is we try to bring governance as much as possible here. So this is the abstract about the project which I had worked on. Now these are the responsibilities which I was working on the project. So we were working on the real-time ingestion, and then the transformation what I was doing was in a Medallion architecture format. So what happens in Medallion architecture is you try to get as much as control for the data, and then you divide it into layers of it. For example, you will have a bronze, silver and gold. So bronze layer, what you do is you dump the data as soon as you get the data, right? You dump it here, so that this would be the ground truth. And then next you will have silver layer and then the gold layer. In silver layer, you do all kinds of transformations for it to pure the data, and then you have gold layer where you will have the business perspective for it. So we were ingesting the data from the API, and then we were processing the data using Medallion architecture, and then we were using the data storage through PostgreSQL, right? So and then the complete process should also be automated, right? So we were using the Airflow for it, where we can have governance into it. You can have the dependencies divided into it. For example, if you are orchestrating the data, you must have the dependencies. For example, you will have upstream data and downstream data. So for example, if you want to create make french fries, you must first peel the potatoes, grate it, and then fry it, right? So to fry the potato, you must have grated it already. So this would be the dependency for it. In order to complete task B, you must have completed task A. So these are the dependencies where you can, these are the dependencies which are required for it. For example, if at all something, the dependency A fails, you would not be able to move to dependency B. So you will have parallel dependencies, you will have sequential dependencies, things like that. So I would say that beyond just the ETL pipeline, once this ETL pipeline is done, the job does not end there. The scope for a data engineer is not just still here. You can also increase your spectrum here. For example, once you push the data, as my friend was telling, you can also move towards NLP. You can also move towards machine learning models, where once you dump the data, you can also work towards its real-time analytics. You can build machine learning models. Data governance in the big data governance is must and mandatory. For example, if you scrape the data, if you ingest the data from an API and then push it to a data warehouse, and then if at all the data at the warehouse is not accurate enough, then the complete pipeline breaks down. So the governance is very important. There is actually a saying in big data, trash in, trash out, or garbage in, garbage out. So if you pull the data and then the data is usually in a raw format, so it is more like a garbage, you try to process it, and then if at all you don't process it well enough, so it is like you're just taking garbage from one end and then shoving it to other part. So this is what I would like to say. And then the key takeaways I would tell, for example, to get into this data engineering domain, would have certain skill set, like so and so would be the expectations from your manager or from the field. So what I would say is, data engineers, they are critical in terms of building things. For example, if everything is working very fine, data engineers are almost invisible. But if at all the pipeline breaks, you are the first person. People expect you to jump on the hot seat and then try to troubleshoot it. And then to start your career into big data, I would say that scripting is mandatory. You need Python, you need SQL, you need one of the big data tools, distributed systems like PySpark, one of any cloud service providers like Amazon or Azure or GCP. And then I would also tell you that usually I see this problem in new joinees or freshers, that they try to make projects as many as possible, but it is not like that in data engineering. A single project which has proper data modeling on that, and then you can actually solve a problem. For actually solve a real world problem, people would go head over heels for you than a person who is just building a couple of projects which is not actually solving the real world problem. So to get into data engineering, big data, try to focus towards a real world problem and make a small solution for it. If you have a problem and then you contribute towards 20% of the solution, that is a great thing. You can do it instead of actually just building some projects and then which are not going to be useful in the future. With that being said, these are the basic tools you need for big data, what the industry expects from you, and then what are the things you need, like in order to get into this domain, what are the basic necessities for you. So these are the things what I can tell you. And then I also explained about the basic projects what I have worked on, so you might take some kind of idea from it and then build your mini project or thing like that. So yeah, and I'm open towards, I would love to get some questions from different backgrounds as well, as I pitch the idea, as I tried to make clear like what a data engineer is. It is very confusing between data engineers and data scientists. Like people get confused, like do data engineers also build models? Yeah, they do build models, but it is more into data and ML ops, right? But a pure data engineer is mainly focused towards data ingestion till data warehousing and the orchestration process. Yeah, so this was the complete presentation, and I would love to get some kind of questions about it. Nobody has a question for data engineers, is it? Oh, hi people.
Sir, how can I find data engineer internships?
Sorry?
Sir, how can I find data engineer internships?
You would have so many platforms, like you have Internshala, you have LinkedIn, you have Indeed, things like that. You just create a project, a nice resume, and then if at all you pitch it to the HR people, if at all you are a very skilled data engineer, right? People go head over heels for you, because things like you will have Netflix, you will have Uber, you will have so many places where data is abundant, and then they also want to build machine learning models, right? So if at all you are very skilled in this domain, people are ready to pay you even 500k a year, right? So try pitching from LinkedIn or Internshala, things like that. It is very easy to get an internship.
Sir, thank you.
Thank you, Jitendra. Anybody else? Somebody else have question for data engineers? Thank you then.
Yeah. Before we wrap up, on behalf of TechBrain, I would like to sincerely thank you, Mr. Syed Rashid Ahmed, sir, for taking time to join us today, for sharing such practical and insightful knowledge with all of us. Your clear roadmap and real-world guidance have surely helped students understand how to approach a career in big data and Hadoop. I would also like to thank you all the participants for actively joining today's TechBrain Tech Talk session. We hope you found this session informative and valuable. To mark your attendance. Thank you, sir, for joining us today.
Thank you, people, for listening, and then thanks for asking questions. I hope I solve the confusion between data engineers and data scientists. I gave some brief about what the industry expects from you, like what are the skill set you need. I hope this actually helps you, and then this motivates you to be a data engineer, and we would like to have more data engineers in the field. Thank you.
Thank you, sir. To mark your attendance and receive your participation certificate, please fill out the feedback form that we are sharing in the chat now. Kindly make sure you submit the form before leaving the meeting. Also, don't forget to follow TechBrain on our social media platforms to stay updated about the upcoming webinars, internships, and job opportunities. Once again, thank you everyone for joining us today. Have a wonderful evening, and we are looking forward to see you in our next TechBrain talk.